Draw your separation line. It's not a big leap, just a little leap. 1/5 minus 1/20th. Now, is this going to be a lot different, do you think, or the same? What do you think? Different? A lot different or just different? Different, because it's subtraction. So if we go back to what we just did, 1/5 is how much money? 1/5 was how much money? 20 cents. And how much cents are we taking away? 5 cents. What's 20 cents minus 5 cents equal? Rev? 15 cents. And then we rewrite that as a fraction. So it's 15 cents, 20 cents and 5 cents, subtracting, sorry, is 15 cents. What's that decimal number? Yep. 15 hundredths. And then we have to reduce. So what divides into 15? That divides into 100. The greatest common factor. 5 is the biggest number. So 15 divided by 5 is 3. And 100 divided by 5? 20. 3/20ths. Good. Now there's another way. Let's try this way. I like this way. What's this thing going to be? Slinky. A line, number line, yeah. Now, if we are starting with which amount? Let's use our money amounts. So we had 20 cents and 5 cents. This is just another way to subtract decimals. This is just another strategy. What are we starting with? What are we starting with? Moose? Nope. Nope. 20 cents, right? It's 20 cents minus 5 cents. So over here, we're just going to put a mark, and we'll put 20 cents because that's what it is. And we're doing subtract 5 cents. So I'm going to go backwards. How much? 5 cents. This is just another way of you visualizing this math problem. That's all it is. So if we take 5 cents from 20 cents, we end up at what? 15 cents. We still have to rewrite that as the fraction and then reduce, but it's just another way of visualizing it. What if we do it this way? Let's draw another number line quickly. What if we start here at 5 cents? What if I build up? If I build up to, what's a nice round number from 5 cents? After 5 cents? 10 cents. So that would be adding how much? 5 cents. That gets us to 10 cents. So we're at 5, and we're going to build up to 20 cents. So now we're at 10 cents. From 10 cents, what should I add on to that to get to our number? 10 cents. So we're going to draw our arrow. We're adding 10 cents. 10 cents plus 10 cents is what? 20 cents. So now we're at 20 cents because I added 10 cents. And now how do we figure out what the answer is? How do we figure that out, Hallie? We add our jumps up here, right? We went 5 cents and 10 cents, which equals 15 cents. And then we convert it to our fraction. Very good. Here's another one. Should we try this one, Viv? Is this okay with you if I write this down? Thanks. We're going to separate it first. 2/5 plus 19/20. That's a goodie. 2/5 and 19/20. So no longer are they just unit fractions with a 1 on the top. Now we have multiple. So if we look at what we just did, how does the previous problem help us with this? Look at our previous problem. Clara?
Our previous problem had both denominators and 5 and 20, and so is
Yep.
we had
We have the same denominators. That's one way it helps us. So how are we going to set this up? 2/5 is how much cents? Using your previous problem, folks. 40 cents. Why?
Because 2 times, no, 5 times 2 is 10. 2 times 2.
Okay, there's a simpler reason. I have 2/5 here. I had 1/5 here. How much was 1/5?
20.
Was 20 cents. Now I've got two of those, right? So now I got 40 cents. How about 19/20ths? Previously, 1/20th was how much? Look what you just did. How much was 1/20th?
5 cents.
5 cents. So that means 20 of those is going to be how much? 20 nickels. $1. So what's 40 cents plus $1? $1.40. Then we have to change that to a what? What are we changing that to? A mixed number, right? Because we have 1 and what? 40 hundredths. Are we going to leave it that way?
No.
Well, why can't we leave it this way? Why should we know, or why are we working on learning that we have to know those two numbers can't stay that way? We talked about it yesterday. They're both what? They're both even. What divides into 40? That divides into 100. The greatest common factor, the biggest number that divides into both. What do you think, Fensky? 10 would work, right? Would it work?
Yeah.
But it's not the greatest. There's a bigger one.
20.
20. What's 40 divided by 20? 2. And 100 divided by 20? 5. 1 and 2/5. 10 would work. Then we have to do what again? What do we have to do again?
Go down again.
Reduce again. Yes, that doesn't matter. Yes.
Isn't 19/20th not a whole?
I'm just going with what he said.
19/20th.
Were we wrong? Is 19/20th not $1?
No, because a whole.
Well, no one corrected
It
us.
would be 95 cents.
A whole.
You guys go like this, everybody. Left hand. Raise it.
We just realized that.
Okay, now go this way.
I realized that a while
So now try both. So they both work. Oh, Ella's are broke. Try again. There we go. So what did we do wrong? No one spoke up.
I was waiting if I got it wrong.
So what is 19/20ths?
Um,
How much is 19/20ths? 1/20th was a nickel.
1 and 6/20.
How much is 19 nickels? 95 cents.
Yeah.
So let's do this one again. Now we got to do more work because no one spoke up and say, hey, that wasn't right.
Well, I thought I was wrong.
2/5 plus 19/20. Oh, you don't have to do this. Sorry. I just habit. 2/5 we said was 40 cents. Is that correct, everybody?
Yes.
All right. Plus 19/20ths you now said was how much? 95 cents. Yeah. Speak up if you see something wrong.
I thought I was wrong.
40 cents and 95 cents is how much cents then? Last time we got $1.40, so it must be what? $1.35. And we rewrite that as what mixed number? What's that going to be? $1.35, Fensky? 1 35 hundredths. That's okay if we have to redo it again because now we can practice reducing again. What's the GCF for 35 and 100? The biggest number that fits into 35 and 100 equally. It's not as big as we would like. What do you think, Chase?
5.
5 fits. So it'll become 1 and what's 35 divided by 5?
6.
In some countries, but in America, 35 divided by 5 is what? 7. Yep. 7. And 100 divided by 5? 20. So 1 and 7/20. Very good. That's using the money model.
I should think about this next time you speak up.
No, well, yeah, you should. Raise your hand. Raise your hand, that helps, then we can count.